quick recap what we have discussed yesterday so that, you know, because that is required. Let me open the Epic Pen. Okay. Okay. So when we were talking about, you know, when we were talking about the Docker yesterday, so we have discussed that Docker is a containerization tool, right? So what is the need of the container? Need of the container is that if the modern way of writing the code is the microservice kind of approach, where we are having one application, say banking, and banking needs internet banking, withdraw service, deposit, and customer care, right? So all these are implemented in the form of container. So these are loosely coupled. You develop separately. You means the development team, they develop it separately, and you invoke into your application. Okay, so banking is not adding the jar file of this. Instead of that, there is a URI or URL, you can say. So there will be some URL, right? So that URL, you are invoking it here. So that is the microservice approach. And in these kind of things, we prefer container, because if we are using the automation process by using DevOps, so we need these these things should be under the automation. Plus, these should be having a zero downtime. Zero downtime, how to achieve that we will see in the container orchestration. Okay. Now, also we have discussed that if you want to create a container, first you need a Docker image, right? So Docker image is nothing, but it is the one which is required to create a container. So when you create a container, in the container is mainly used for the application deployment. So your application is running inside the container, and container needs a Docker image, right? So for example, you want to deploy your Java-based application. Instead of installing Tomcat on your system and run it, what you can do, you can take the Tomcat Docker image. So there is a Docker image which is Tomcat on Docker Hub. So you can download from the Docker Hub. So this is my Docker Hub. You can go there and you can download the Tomcat Docker image, and then you can run it as a container. So Docker image is read-only. You cannot modify it once it is created. Docker image is set of instruction layer. So yesterday when I was deleting the Docker image, you have seen that there are many files get deleted. The reason is that because those are the encrypted layers which is in the Docker image. You cannot you know kind of it's not a file. Okay, it's not a file. So it is something which is collection of all these instructions, and jointly it is make one Docker image. Okay. Okay, for a developer point of view, that knowledge is enough that we are downloading the Docker image, but if you go in deeper level, then we need to know this how instruction layer works. That we will see in the Docker file. We will see how we can use the Docker file, and right, so those things we will see, right? So yesterday we run certain commands. We have used Docker pull and the Docker images. name. For example, Ubuntu is a Docker image. Okay. So what it will do, it will go to the Docker hub and download that image. So for that, we need the internet connection because this is cloud-based system. This is Docker hub. So Docker hub is a cloud-based repository of all the commonly used Docker images, right? So there are some images which are public. So public images, we can download it, you can download it, I can download it, my neighbor can download it, right? Anyone can download it. So there is no restriction. But if it is private, then only the authenticated users, those who have created or uploaded or have the access, so they can only access it. Okay. So far Ubuntu, Nginx, all these are the public Docker images. Few Docker images, a few things I want to discuss. Some images are there. One image is Tomcat image, right? So you can use similar way as you use the Tomcat on your machine. So this is Docker image, which is Tomcat. Second is Nginx. Nginx is a web server which is widely used. Okay, widely used. This is very important web server. So we are not going in deep of this, what is Nginx, but we will take it as a Docker image and we will deploy our application by using Nginx or maybe some basic. So I will be just taking it as a Docker image because it's a web server. Okay. S- So that we will be using in our examples. Third one is the Apache. Okay. Apache is again very popular web server and it has Docker image called HTTPD. Okay. And this is a again web server. So this Docker image also we will use very frequently in our examples. And fourth one is the OS related like Ubuntu, CentOS, right? So those are the Docker images also I will use. Now, one more thing I just want to point out here, which is related to the Windows Docker images. Okay? Windows Docker images. See, earlier, because I'm in the development more than 20 years, so I was a Microsoft application developer. So when I was developing the code for Windows-based application, so to implement this or to execute those uh, my code or my programs, so I need the Windows operating system. So there was a restriction if I develop the .NET based application, so that will run on the Windows machines only. It will not run on the Linux or other operating systems. But now it's almost 6 to 7 years now. Windows or Microsoft has realized, right, that that will not work because now it's a open source freeware, right? See, Java, it can run on all the platform. Python, you can run it on all the platforms, means Windows, Linux, Mac. So now Windows .NET, so they are having now their own .NET Core. So this .NET Core, now Microsoft has created this .NET Core, which can run on Linux, Windows, and Mac operating system. .NET is separate, .NET Core is separate. Okay? So it supports the Windows. You can implement this code on the Linux, Windows, Mac operating system. So you have heard about PowerShell. So PowerShell also now you can integrate with your Linux, Windows, or Mac operating system. So now Microsoft also, uh, you know, working on these platforms, so that if so now if you want to develop a Docker image, okay, so there is a Docker image, right, which is using the .NET Core application. So now what we can do, we can create a Linux based, see, if you see most of the, I would say almost 80% or more than that, images which are the Docker images, these are Linux based. Okay, some of them are Windows based also, but that is Windows Core. Windows Core is also CLI based, right? So .NET Core application, now you can deploy it on Linux, and Docker image we can create, means, for example, you are taking Ubuntu image and you will say, okay, I had developed a program in .NET Core, so I can deploy it inside the Ubuntu and I can create a Docker image. Okay, so now Windows based, not desktop based applications I'm talking about. These are microservices based, web application based. So those things also you can, in Windows, you can develop in .NET Core, and you can create your own Docker images. And there are some Docker images are also available. So these are the Docker images which we will be using in our examples. And I just wanted to, you know, discuss this particular Docker image which is related to the Windows. Is it clear, these 2 points?
Mm.
Okay. Now let us do one thing. Let us talk about now container. Image we have already seen. Image is read only. So when we say my Docker image is read only, then basically what is happening, that image is having the instruction layers, and those are read only. What is the instruction layer means? Instruction layer means, for example, whenever a Docker image is created, so it is having some file structure or file system. Okay, so if you are using Ubuntu or Linux based, right? So its file system is similar to that operating system. There will be root. Maybe there is no home directory. There will be a bin directory, root. There is a etc directory, root. There is a opt directory. Okay, and you can use the same commands which you are using in the Linux. So those commands we can use when we use this Docker image, but these are read only. You cannot modify it. Now, if it is read only, it means it is something, for example, if I say read this paper, but you cannot write on this paper. Now you say, oh, I see there is a change required. So in the change required, it means you need to cut some line, or maybe you need to add some line, or you need to modify something. So that we cannot do in the Docker image. That's why container comes into the picture. So container is the deployment unit. So if you are having an application and you want to deploy that application, how we were deploying so far? On virtual machines or on physical servers. So instead of that, for example, I have my internet banking application, and this is a jar file, and I want this jar file is to be deployed on a container, because it should be a deployment, right? So, but now I'm going to use container, and container needs a Docker image. So you need to check what is the suitable Docker image for that, right? For your container, if you want to run a internet banking application, consider it is developed in .NET Core. So you can say, okay, I will take my .NET Core Docker image. Now, Docker images are very customizable. Means people, they are creating Docker images as per their requirement, right? So container is a deployment unit. So you will deploy your code on the container, right? So let us create a container. So what I'll do, I will start my AWS, right? The one which we have created yesterday, that EC2 instance. Let me sign into that. Oh no, I have created the Azure, I believe. Portal.azure.com. Right. I'll go to my virtual machine. And I will start this machine. So it is getting started. Meanwhile, I will open my MobaXterm. You guys are able to hear me?
Yes,
Yes,
yes.
sir. Yes, sir.
Okay, okay, okay. There was, looks like some disconnection. Okay, so my machine is in the started mode now. So I will use this one. I will clear the history minus C. Now what I'll do, first we'll talk about the containers. So containers are the deployment unit for the applications, and it needs a Docker image. So first we'll talk about first type of container, which is called the attached container. So as soon as you create a container, the control goes inside the container, and when we exit from the container is in the stopped mode. Okay, so let us see. So if I say Docker, all the container commands you can use run directly, or if you want to use the management commands, then means more explicitly you want to say that I want to create a container, so you can use the container run also. But container, that word is optional. So if I say Docker container run, and I'll say I want to go inside the container. Okay. So if I don't mention this inside the container, and I simply say Docker container run, and I will use the Docker image Ubuntu. And if this Docker image is not downloaded on your system, so that image should be there on your system. If it is not there, then it will download the image first and then create the container. So here what we are doing, we are creating the container, okay, creating the container, but uh, but it will execute and then stop. So now I have executed this Docker container run Ubuntu. Something happened. Let us see. So to see all the container, Docker ps -a command. So here you can see there is a container get created, which is in the exit mode. It got created 7 seconds ago. But then you might be thinking, what is the use of this? See, for example, you want to run a job, and that job code or script is written inside the Docker image. You want that script is to be executed. So there is something called command. Okay, so that we will discuss in the Docker file today. But you want that as soon as I run my container, that command should be executed and then stop. So in that case, you create a container without going inside the container. Okay, so this container is created, and this is the container ID. Every container is having a unique container ID, and it is using the Docker image Ubuntu, and it has executed this command, and it got created 10 seconds ago, but currently it is in the stop state, which is exited. And this is the some dummy name, random name is basically assigned to this because we have not given the name. Now, second case, I want to create the container, and then I want to go inside the container, attached container only. So I will say Docker container run -it, and then you can give the Docker image. I'll say Ubuntu. So Ubuntu is my Docker image. Now see, I'm inside the container. See, this is changed. Root add something, right? So this something is nothing, but this is the container ID. So there is a container get created, and that container is having this container ID. Now at this moment, I'm inside the container. Okay, so I'm inside the container. So if I say ls, so these are the Docker image files which is inside the container. Okay, so container is a write layer. Write layer means Docker image files are there, which is available for the container. Now, if you want, you can create a directory. If I say mkdir test, so test directory is created. If I say ls, so that test directory get created inside the container. Okay,
So
inside
why the
the
container ID is different? Like it is showing earlier, it is CEC
that was
to
a
now.
different container. That was a different container. This is a new container.
Okay, okay.
So that container got created and stopped. Now I'm creating new container with this command. So it has created one more container with new container ID. All right. And now I'm able to create a file or directory inside that.
And sir, suppose if we are trying to run same container again and again, like Ubuntu you started and then you stopped. Again you are starting this Ubuntu. So it is creating a new container or it is
Yes.
restart.
So whenever you run the container run command, so it always creates a new container.
What about
Okay.
the exist one, the stopped one?
That if you want to use, you can start it again, and we will see how to start. And then we can use that also. Okay, so stopped container can be started, and then we can go inside the container. All right. So now at this moment, I'm inside this container, and this container, I have this test directory inside that, which I have created, and I am able to create that test directory. Now, if you want to come out of this container, you need to run the exit command. So now I'm exited from the container. Okay. So I'm exited from the container. So if I say, now see the prompt also gets changed. I'm back to my operating system, right? So, right. Now, the second type of container is called the detached container. These are mostly used. So, so these containers are running in the background. Okay. So here, see, when I was in this container, I cannot do other work, right? Until unless I exit from that container. So, but if you want something be asynchronous, then asynchronous means running in the background. So in that case, you can use the detached container. Let us try that one. So if I say Docker container run -IT. What is -IT? -IT is interactive terminal. See, when I created my first container, right, this container, so I used Docker container run and I did not use -IT. That is why I was not able to go inside the container, right? Now, in second command, I have used Docker container run -IT and the so -IT interactive terminal. So what it has done, it allows me to go inside the container and I can interact with the terminal. Okay, so -IT option is required if you want to go inside the container. If you don't want to, you just need to execute it, then this -IT option is not required. So this is a optional argument. Now Docker container run -IT and I will say -D option. So -D option indicates detach mode, means I want to create this container in the background. So for example, if I say I want to use Ubuntu Docker image, right? So now the container got created. So if I say Docker and ps minus a, we will discuss that command also. So you can see that this container is up and running. This container is not in the stopped mode because this is running. The other two were stopped because those are the attached containers and this is the detached container, right? So this container is up from last 11 seconds. So now container is running in the background. So see, whenever you install Docker, right? And if your Docker is not working, so there is systemctl. If you want to see Docker is running as a service, systemctl status Docker. So Docker is running as a service and it is active, right? Now, if I say um, uh, this command, right? So Docker ps minus a. So my Docker daemon, right? Docker daemon is my service. And it is handling all the requests which I am sending. Remember yesterday when I was talking about the Docker engine architecture, so I told you that there is a CLI. So this is my CLI when I am able to run the Docker command. Okay, so Docker CLI is sending this command to REST API, and REST API is sending to the Docker daemon, which is that service, and Docker service is sending me the response this through REST API, right? So this is how internally it works. Now there are three containers are there. One, this is in the detached mode, which is running in the background. And so Docker is a process. Actually, if you think about it, Docker is running as a service. So service is nothing but a process is running in my system. Okay. Docker, inside the Docker, we are having networking, other concepts, but that is related to that process only. Okay. So now three containers are there. So first container, this container is in the detached mode. These two are attached modes. So now we have discussed two things. One is attached container. Attached containers are those containers where you go inside the container directly, right? If you use -IT option, which is interactive terminal, means I can see the terminal of the container. If you don't use this -IT, right, and attached mode, then you cannot go inside the container. What is the use case? For example, there is a Docker image, some script is to run, and you don't want to go inside the container, then you don't use this -IT option. Second is the detached container. So the container which is running in the background. Okay, so it is running, it is doing its job. Okay, and and right, and it is not in the stop state. Now the thing is, this is container ID, which Docker image it is using. Command. This command get executed as soon as your container gets started. It got created. It is currently up. Ports we will discuss. And this is the name of the container. See, name of the container or the container ID you can use alternatively. For example, if you want to delete the container, you can use container means Docker RM this, or you can say container ID. So if we remembering the name is easy as compared to remembering the container ID. So that is why we will give some meaningful name. We can rename this. So let us uh, rename the container. So I will say Docker container rename, and I will use, I want to rename, you can use container ID or container name, and I want to call it as C1. Now if I say Docker uh, PS minus A, so you can see this container name is changed to C1. You can give any name, right? Same way, I want to change the container name uh, of second container, which is this one, to C2. And similarly, I want to rename the container, which is this one, to C3. Right? Guys, just 1 second. I'll come back. All right, I'm back. So, right. So we were talking about the renaming the container. So I have renamed all these containers. Now, if I say Docker PS minus A, so you can see now all the containers are renamed, right? Now, what I want to do, I want to means I want that this container is to be created during the creation time. It should have a name. So then you can say Docker container run minus IT. You can put this option name. So name of the container, say C3, C4, C1, C2, C3. Yeah. So C4 container. And I want to use a Docker image, say CentOS 7 image. So now what it will do, it will go to the Docker hub first and download this Docker image and then create the container. See, this image was not on my local system. So first it has downloaded that Docker image and then it has created the container, right? Now the container name will be C4. So if I say Docker PS minus A, so you can see there is a new container which is 8 seconds ago it got created. It is using the Docker image CentOS 7. This is the container ID which is unique. This command will be executed when the container get created and name of the container is C4, right? So if you create a container, then that container is having the the name now. Okay. Now let us discuss one more use case. Now containers are supposed to be lightweight. Okay, container should be lightweight. So you need to choose the appropriate Docker image, because whatever the Docker image you are using, so that is read only, and container is your having a write layer. Okay, container is having a write layer. Then read layer plus write layer, it becomes the size of the container. Okay, it becomes the size of the container. Now let us see with the example. Okay, size of the container. So size of the container is Docker image size plus write layer size. Write layer means whatever you are adding. For example, I have added a file which is 1 KB. So, and my Docker image size is 70 MB. Now the total size of container will be 70 MB plus 1 MB, for example, 71 MB, write layer. Okay, so if you want to modify something, that is through the write layer. Now, if I say Docker and images, so here you can see my Ubuntu latest image size is 78.1 MB, right? And we have created this container Docker ps-a. So we have created this container, which is C2 and C3. So if I say Docker ps-s, so now here you can see um, this container, right? C2 and C3. Okay, so these are not showing because I did not use -a. So I need to use -a, -s. Right. Now here you can see the, let us take this example, C3. So C3 is size is 0 byte and virtual size is 78.1 MB. What does it mean? It means that my Docker image, so this is virtual image. My Docker image size was what? 78.1 MB, right? So this is 78.1 MB, right? And there is a 0 byte for the write layer. Okay, there is a 0 byte for the write layer. So it means is total size of my Docker image is, sorry, container is 78.1 MB. Now here you can see this is CentOS 7, right? In CentOS 7, my total size is 204 MB, 204 MB, right? And I did not do anything, right? I did not create something in so my writable size is 0 byte. So total container size is 204 MB. Do you understand this? How we can container size means something which is, see, whenever your container is running on your operating system, it needs memory, CPU, etc., right? So now when it is running, it needs 204 MB of space minimum. If it is running, for example, you are running 10 or 200, we'll take 200 into 10 containers you are running. So it needs 2000, which is 2000 MB, means 2 GB of space. So you need to have that much space on your system, free space. Okay, so this is how we can find the size of the container. And this is important when you are working as a DevOps engineer, because you need to know that how much resource